So particularly in this video, I'm going to review correlations, and I'm going to talk about two things. But if you need more review, you should go back to the bivariate descriptive statistics phase. Particularly in this video, I'm going to talk about the direction of a correlation and also the strength. So remember, direction is if it's positive or negative, and strength is how weak or strong it is. So if it's positive, a positive number, it's a positive relationship. If it's a negative number, it's a negative relationship. And then we have strength. You can go from 0, which is very weak, to either positive 1, which is a perfect strength, or a negative 1, which is also a perfect strength. Okay? If you need to review how to calculate a correlation, please go back to the bivariate descriptive statistics video. So first I want to talk about direction. And so if you have a correlation from -1 all the way up to 0, but not 0, we have a negative correlation. And then anything above 0 all the way up to 1, positive 1, we have positive relationship. And if it's 0, then it means there's no relationship. So if we have a negative relationship, that means as one variable increases, then the other variable tends to decrease. So let's say we have study hours. So the more you study, we'll say that your sleep decreases. So I guess you have to give up one thing in college, right? Sleep, studying, or having fun, and so maybe if you choose to have less sleep. So if you put a dot where your study hours and your sleep intersect, so this dot right here represents one person. So that's one person's studies hours and their sleep. So they have a lot of sleep, but they don't study a lot. And then say this person here, they don't sleep hardly at all, but they study a lot. And then you have other people at other places here. And if you have a negative relationship, that means as the study hours increases, your sleep tends to decrease, or that they're going in opposite directions. And we can put a line of best fit in between these dots, so we're just trying to represent all the dots with one line. And we can also put lines at the means of these two variables. So we'll call this x bar, this line. This is the mean of the study hours. And then we can put a line about where the mean of the sleep hours is. Well, it's about right here. We'll call that y bar. And where these two means intersect, we could put a dot there, and that dot is actually on the line, of best fit here, and that'll be important later on. Okay? But also you want to see that if dots are mostly in these two quadrants, see how putting the two mean lines here makes 4 quadrants here. And if we go to the top left quadrant, those will make your correlation, if dots are in that quadrant, it'll make your correlation mostly negative. And if it's also in the bottom right one, it'll make your correlation negative. So most of your dots, which most of them are in these two quadrants, will have a negative correlation. See, there's only like one dot that's not in those two. And then now let's go to the positive correlation. So that means as your one variable increases, your other variable also tends to increase, or as one decreases, the other one decreases. It's just that they go in the same direction. They're moving together, versus a negative correlation where they're moving kind of against each other. So maybe we'll have study hours again. but hopefully the more you study, the higher your grade is, so that they move together. So here's your grade. And so, let's say this person doesn't study a lot, and so they have a bad grade. Or you can have someone who studies a lot and they have a high grade, and then you can have people in the middle here. So we just have each dot represents a person, and it represents where their grade and their study hours intersect. Okay, and then you can also make a line of best fit here, kind of represent all these dots, and make a trend line. You can call it also a trend line. And then you can also put the mean lines here, so maybe this is the mean of the grades. And then you can also put a mean where the study hours are, the mean of the study hours, and so we're going to call that x bar. And again, where this intersects here is on the line of best fit, or on the trend line. You can call it the trend line. And if things are mostly in this bottom left quadrant, and this top right quadrant, and the quadrants are made by the mean lines, then we'll have a positive correlation. Okay? Now let's talk about no correlation. So if we put those lines again, so this is x bar, and this is y bar. If we have dots in all the quadrants, or it's kind of random, so we tend to have dots in all the quadrants, and it just kind of random, then this would be no correlation, or you get something around 0. And if you try to put a line of best fit here, then maybe it would look something like this. It kind of has no slope, a 0 slope. So your slope is 0. So this would be no correlation. Alright, now I'm going to talk about the strength of a relationship, or of a correlation. So we can either have a weak relationship, or we can have a moderate, or we can have a strong, but I'm just going to draw out the weak and the strong here. So it doesn't matter what the direction is, it just depends on how close the dots are to the line. So here we have a negative relationship, the line of best fit is negative, but we can have a weak relationship because the dots tend to be far away from the line, a little bit more spread out. So maybe the dots look something like that. But if you have a strong relationship, here's a positive relationship, but it doesn't matter that it's positive. What matters is that the dots are really close to this line. So you can see for the strong relationship, the dots are close to the line. For a weak relationship, the dots are spread out. Alright, now I just want to make a couple of reminders. First of all, a Pearson correlation is only for linear relationships, and so this would be a linear, it's a straight line. That's what I mean by linear. It's a straight line. So if you have something like this, the dots kind of tend to make a relationship that's in a straight line. That's okay. So this is okay for Pearson's correlation. But if you have a trend that's curved, it's non-linear, like say something like this, then you can kind of see that there is this trend here, but if you made a line, it would be curved. And for a Pearson correlation, this is not appropriate. What will happen is the Pearson correlation will be about 0 for this. It will make a line, tries to make a linear line, and the linear line, it tries to make the distance between the line and the dots as small as possible for all the dots. So it would make this straight line that is horizontal, and it would say that the Pearson correlation is 0. But as you can see, there is a relationship. It's just non-linear, it's curved. So the Pearson correlation is only good for linear straight line relationships, and also it's only for scale variables. So scale variables are things you can average. They're numerical. So this wouldn't be good for categories like gender, race, or other things like that. It's only for scale numerical variables that you can average. So just remember this when you're doing correlations. And then we can also have no relationship. And that would mean that if you had a line of best fit, it would look like this. It would be flat and it has a slope of 0. But what happens is that the dots are just kind of random. And you just don't really see any pattern. And then if you talk about the correlation coefficient, which is the number, you can tell how strong the relationship is. So if we have a 0, that means there's no relationship. Then we have a positive 1, that's a perfect positive relationship. If we have a negative 1, that's a perfect negative relationship. And then you have numbers in between. And according to Cohen, this is a psychologist, he says for psychology, now it's different in other disciplines, but anything from 0 to -3 here, this is weak. Or anything from 0 to +0.3, that's also weak. And then anything from 0.3 to 0.5, so -0.3 to -0.5, or +0.3 to +0.5, that would be moderate. And then anything above that or below that, so anything from -0.5 to -1, that would be strong. And anything from 0.5 to +1, that would also be strong. So that kind of gives you an idea of how strong the relationship is if you have the Pearson correlation coefficient, which is the number that we calculate.